So we're finishing off chapter 7 with 7.5 proportions in triangles. I'm going to jump straight down to that first definition. When two or more parallel lines intersect each other, we're going to have proportional segments form. And some of you guys already noticed that this was happening with your similar triangles that we're solving with. But in this theorem that we call the Side-Splitter Theorem, if a line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionally. So not quite a midsegment, doesn't have to go through the midpoints of the two sides. But if I have these two lines that are parallel to that third side of the triangle, whatever ratio I break up one side into, so if I break up that ratio XR to RQ, and I put some numbers there to help visualize that, if XR was 1 and RQ was 3, then the other side would be broken up into the same ratios. So if YS was 2, for example, SQ would have to be 6, because that keeps the same ratio 1 to 3, 2 to 6 is in the same proportion. So trying that with some practice, if I want to find missing variables, which is usually how we're going to have these questions set up on a test, if I have my figure set up this way with my parallel side to that triangle, if I break up my ratio, I could write x to 9 will be proportional to x plus 1 to 12. So again, if I look along that same side, the ratio of one part to the part next to it is going to match from one side to the other. So if I set up that proportion, now we just got to cross multiply and solve. X times 12 and 9 times the quantity x plus 1. Just want to make sure that you distribute the 9. And when we use our algebra steps to solve for x, we should eventually get 3 from that first question. So I set up my proportion in the next problem a little bit differently, just to show that there's different ways we could visualize this. The first time we set up the proportion, we looked along that same side to make a ratio. We can also go across the triangle. So if you set up that second proportion, for A, you could find A to 12 is the same ratio as A plus 4 to 18. So you can go either along the same side or you can go across from one side to the other. And solving that proportion, again, just cross multiply 18 times A, 12 times A, but also 12 times 4 gives you 12A plus 48. Using our algebra steps to isolate for A, we should eventually get 8 from that. So a corollary there is that we don't need a triangle to use that rule. We can just have 3 parallel lines that intersect 2 transversals. So how this figure set up, I have 3 parallel lines and 2 transversals that those intersect. The segments that are intercepted on the transversals are going to be proportional. And we already saw a rule similar to this, but that just means that with our proportions, we can go either along that same side. So AB to BC would be in the proportion of 1 to 3. And that should be the same ratio if I use WX to XY on the other side. So 2 to 6 is in the same ratio as 1 to 3. And trying that with some practice, we have our campsite set up. We want to find 2 lengths. We want to find the length of the site A along the river, which I have labeled as a variable A. And we also want the length of site C along the road, which I just use the variable C for. So using that same theorem, I can set up my proportions. I set up the first one as A to 9. The ratio from one side to go across is A to 9. And that will match the ratio that we have completed here from 8 to 7.2. So again, I can go across and it will work with those 2 ratios being equal. And again, just cross multiply and solve, and we should get 10 yards for A. And setting up a similar proportion for C, remember you can either go across like we did for A. For C, I set up that proportion a little different. You can go along the same side. So the ratio of C to 7.2 will be equal to the ratio of 6.4 to 8. We just want to make sure those pieces are in the right order, but I should be able to set it up either along the same side or set up that ratio going across. Because when we cross multiply and solve for C, should also get 5.76 yards. So one other theorem we're going to talk about is triangle angle bisector. So if a ray bisects an angle of a triangle, which we can see is happening here, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of that triangle. So in our rule, if I look at the ratio from CD to DB, so those 2 segments that the side was broken up into, that ratio should also be true for the other 2 sides of that triangle which wasn't intercepted, so AC and AB, or CA and BA. So I added some numbers in there again just to say that we can treat that as a equal ratio again. So if I take the ratio of CD to DB, that was 2 to 1. Using that same ratio, that would be 6 to 3 if I labeled those sides that way. So now let's try and use that rule to find some more missing variables. If I'm looking for x in that first question, And there's multiple ways we can set this up, but one thing you can do is set x to 12, so the ratio from one side of the triangle to the other will be equal to the same ratio from those two segments again. So x to 12 will be in the same ratio as 18 to 10. And we want to make sure that we're matching the correct pieces. If I go from right to left for the first ratio, also want to make sure you're going right to left for the second. So you don't want to mess this up by doing x to 12 and then 10 to 18. Just got to make sure they're in the same order. But if they are in the same order, we should also be able to cross multiply and solve for x to get 21.6. So you can either go across from that triangle, or again, you could look along the same side. So if I set up my proportion this way in part B, you could also set it up as y to 9.6. So the two parts on this side of the triangle should be in the same ratio as 24 to 16. So again, you can either go across like we did in the first ratio, or on this question, I set it up so that we're just matching parts of that triangle. Once I have that proportion set up, again, we're cross multiplying and solving, so 16y is equal to 9.6 times 24. Eventually, when you solve for y, we should get 14.4 there. So we're also asked a couple questions towards the end. What type of segment is drawn inside each triangle? And we can tell that it is an angle bisector, so that segment here is an angle bisector because of those two congruent angle markings. So same thing here. If I draw that segment on the inside of the triangle, I know it's an angle bisector because those two angles are marked congruent. And the last part we're going to ignore because we already did set up our proportions so that x is in the numerator. That's always a good idea because if I just want to solve for x here, we don't really have to cross multiply. You could just think of this as multiplying by 12 because that would already have x isolated. So it's usually a good idea to set up your variables so that they're in the numerator. And that means instead of choosing 12 to x, x to 12 is usually a little bit better option. Make that a little bit simpler. Let's make sure you have these down and we'll look at these in class.